Hey everybody, back again. We're going to start statistics this week, and I'm going to make two videos on this week. One is a recap of the stuff that we did last year in NICATS, and the stuff that's kind of new, and how we represent it and stuff. So it might be worth your while watching this first video. If you feel comfortable enough, etc., etc., you can watch the next video. There's an awful lot of talking. There's not going to be tons and tons of examples. Um, just a couple to go through, but I'll try and keep you entertained through the time we've got this. Alright, so this is statistics in the data cycle, incorporating foundation and higher, aka math. So, data handling. There are 4 steps to data handling. We call it the data cycle, if you like. And you can copy this down into your notes. The 4 steps. Starts at the start. You would pose yourself a question. If you pose yourself a question, we've got to decide on the data and how to collect it. And once we do that, we organise and analyse the data, and after that we interpret and draw results. Depending on how results look and how we've interpreted it, we might need to go back to the start again and pose a new question. So change the question slightly so that we get kind of better results, or if the results come out and they're a little bit ambiguous, we might want to go back and define the parameters of our question a bit more. But we're going to go through each of these 4 stages of the data cycle over the course of the statistics, and hopefully they'll make a bit of sense by the time we come to the end of it. Like I said at the top of the video, we've done some of this already last year. In fact, I covered it in pretty good detail last year, but nothing quite like a refresher, is there? Okay, so you can copy that down, pause the video and copy the data cycle down, or you can lift it from your notes from last year, whichever way it goes. So, how does this work? So if I take you through a slight scenario, should I say, about how this should work. So, if we were playing a game that involved rolling the dice, and I think, or somebody in the group thinks, that a score of 6 will occur fewer times than it ought to, how could we state a hypothesis to investigate and complete the data cycle to follow that? Okay. So the first stage of this is obviously to pose the question. And if we, what's the question going to be? We don't want it to be too vague, and we don't want it to be, open to interpretation. And all these are going to have hypothesis spelled wrong, by the way. Sorry. What can you do? So I'll change it at each time we go along. So I'm going to say the question is, if I roll the dice 60 times, a 6 will occur less times than it should, 10 using the probability that the chances if I roll the dice 60 times, there's an even chance of each of the 6 sides of the dice coming up, or 6th. And a 6th of 60 is 10. So you would expect using normal probability rules that if I roll the dice 60 times, we'll get a 6 10 times out of that. I've stated the question in such a way that anybody could administer this test. Okay, I could probably say if I roll the dice fairly, might be the only other way I could do it, but I'm assuming people are just rolling the dice just in a random manner. I've defined 60 times, and I've defined the parameters by which I want to measure it. So that's the question. So once I've a question done, the next stage to go on and do is decide how I would like to collect the data. And in this case, I'm going to roll a dice 60 times, like I stated in the question, and record the amount of each number that it lands on. So once I've decided how I'm going to collect the data, I've got to decide, how we're going to organize our results, how we're going to sort this out. And it seems in this case fairly straightforward that we'll put results into an organized tally chart, such as the one down here. So the number on the dice I'll fill in as a 1, 2, 3, 4, 5, or 6, and then we will put a tally in. So we could, for instance, if I get my pen, as we go along, we might decide that the first number we roll is a 2. That's 1. Next one we roll is a 1. We roll another 2. We roll a 3, a 4, a 2, a 6, etc., etc. And as we go along, once we get the 5, we do the 5 get, or the 5, as I say, for the tally, so we can count it up in 5s. Once we get the 60, that'll be our results totaled up, and we can then go ahead and put in our tally, our frequencies here at the end. 5, 1. I know these don't add up to 60, but whatever they are at the end, we can put those in at the end. And then hopefully, if we've done our thing right, we'll get 60. If we get 59, we'll know we'll have to roll the dice one more time to record the results, but we want to end up with 60, so it will satisfy what the question was. And that's how we'll collect and organise our results. Last part is we're going to interpret our results. We could draw a graph to represent that data, for instance, but in this case we probably, we can put it in a bar chart and investigate our results and see whether the 6 did occur less than 10 times. If we encountered 10 times, then it doesn't disprove that theory, because the guy says, or the hypothesis stated, that if it occurs 10 times, or sorry, less than 10 times, if it occurs 10 or more, then that hypothesis is untrue. You could also state that the hypothesis isn't quite right, because, you could test it, less times and get those results swayed. It wouldn't necessarily prove it one way or the other. You could do it across multiple groups, etc., etc. And that's the beauty of statistics, and we'll come back to that later. How do we ensure, if we're doing a test where we're not sure whether the outcome of our result is going to be fair and a true reflection, how do we increase the chances of that happening? And we'll come to that when we do sampling and things like that. Okay. So if I move on, I'm going to go into each of these bits in some detail. So I'm going to start off with a question. And there's lots of problems that can arise with questioning, because questions can be, one, vague. So we could have vague questions some way as, well, the last one would be a good one. Something like, I think a 6 would occur less times than it should if I rolled the dice a number of times. Depending on who administers that little experiment, they might roll the dice 10 times. They might roll the dice 60 times. They might roll the dice 100 times. There's nothing to say what it is, what the parameters of it are. They also might decide on how often less than it should means. I mean, there's no parameters for it. Another example would be if I asked a question something like, are young people fit? Or do people who smoke die young? Those things, words like young and fit, are subjective. So, depending on who the person that asks it, what their opinion of what young is, they might have consider different person to be young. So, I'm very, very young, as you quite rightly know. I'm a very young man, and but some people might look at me and say I'm old. I mean, they'd be crazy, but they might say that. Some people might say I'm fit. I'm not, but some people might say I'm fit compared to their own relative fitness, etc. So you want to define these bits a bit more exactly, or put values on them is a good way of ensuring that you're getting better questions. So if you look at your question, ask yourself, if I handed this to somebody else, would they administer the test or the experiment exactly the same way I would? And how can I ensure that they would? And this comes about through going through the data cycle and maybe going through the results once or twice and realizing that, no, I didn't quite get the results that I wanted to there. I'm going to have to go back and ask my question again in a slightly different way to get the results that I want. The second problem can be leading or biased questions. So if you ask somebody a question in a suggestive way, or put emphasis on certain words that are not quite right, something like, are you overweight? Right? Or, you're overweight, aren't you? Something like that. Are you overweight is probably more embarrassing than it is leading. The lower leading one would be, you're overweight, aren't you? It's like enticing an answer for people to go, yeah, I am actually, yeah. I would consider myself to be overweight. Now, it's still a vague question because you would define the parameters of what overweight states, but the leading question is like drawing the positive or the response that you want out of the person that you're asking. So some marketers can skew results if they ask the question in the right way, or lawyers would ask leading questions. So they would lead the witness in this, basically, this is what I want you to say to support my case. Personal or embarrassing questions are slightly different. God, spelling in there is not very good, is it? Anyway, Personal embarrassing questions, things like what age are you? If you ask people what age they are, some people will be embarrassed, and especially in questions like that, which can be the first part of it, like a series of questions. If you start off with a question that somebody's uncomfortable on and lie about it, they're already in the mode of lying about all their answers as they're going along. So be careful when you're asking people personal embarrassing questions. Something like what age are you? You could ask people what category of age they fall into, and if you make the spread of ages wide enough, people are quite happy to go, well, I fit in there. I fit in there without necessarily, giving too much away about themselves if they want to be a bit more close guarded, especially if you're asking strangers. They will more likely pick a category, and most of the surveys that you see coming through your door will have categories for age and things like that. There are other personal embarrassing questions, weight, sometimes marital status, things like that can be embarrassing or a bit too personal for people to be comfortable answering. The last kind of section I'm going to cover is errors in questions. So not covering all answers or answers overlapping. So if I'm giving somebody a age ranges to fall into, I could, what age ranges do you fall into? Well, let me just get to the end here. I'll actually type them out rather than write them, because as you've probably seen, the writing can be, not great. So if I do under 16 as one category, and then 16 to 21, and then 21 to 25, for instance, there's an overlap in those answers. I'll actually put in the next one 30 to 40, something like that. I mean, there's other problems with this. The age ranges are, different sizes and all that kind of stuff, but there's answers overlap. If you're 21 years of age, which one do you tick? Do you tick the 16 to 21 or the 21 to 25? So if you get a situation like that, you want to avoid that. You'd want to go 22 to 27 or something like that as your thing. So the 21 appears in two categories. So it can create some confusion. The other bit you can see is that what if you're 26, 27, 28, or 29? There's no option for 26, 27, 28, or 29. Okay? So you want to be careful of those two things. Make sure you cover all options and that you don't have any overlap of categories, like 16 to 20 and then 17 to 24. You don't want to create any confusion, which is why people will sometimes test their questionnaires and do things like that. Okay? We're all going great. Let's do another example. You're asked to carry out a traffic survey in a busy street for a period of 1 hour. You have to find, by whatever method you decide, how you would determine the most popular colour of car in that time period. So what I want you to do is design the data cycle for that again. So how would you ask the question, or how would you determine the most popular colour in that time? You can pause the video, give it a rattle, or keep it rolling, and I'll give you one possible solution. Okay. So if somebody was setting out to do this, they could just go out with a blank sheet of paper and decide, right, I'm going to write down the colour of every car that passes me. Right, so they could just write down the first car that comes along is let's see, it's possibly blue. Okay, the next one's red, the next one's another blue car, the next one's yellow. Oh God, you don't see too many yellow cars, do you? Etc, etc. The next one could be green, even though green cars are really unlucky. Some people just are rebels. And you could do it that way, but it wouldn't be too long till your hands get sore, or things like that. So better thing to do is to maybe define some colours beforehand, popular colours, and make yourself a table. So actually, rather than typing that out there, I'll put myself in a little table. So I'm going to insert another couple of rows below. There we go. So we could say blue already. We could say red. We could say yellow. We could say green. We could say silver. Whoops. We could say black. We could say, I'm missing other really important colours, I'm sure. You might see the odd purple car, I suppose. Purple and white. Right. Now, again, those colours are subjective because what one person might consider to be a very definite blue, somebody else might consider to be, a greeny blue or whatever. Doesn't, that's those things. But if you're trying to capture this information, that would be one way of doing it. We can have our tally here and our frequency then at the end. And if somebody was going out in the road, it would be much easier to tally away at this as they're going along rather than write the names down. That would be much easier way to do it, especially over the period of an hour. You could have multiple people doing it. You could have 3 people carrying this out so that they do it in 20-minute intervals so that people wouldn't get tired and then subsequently affect the results. But that would be that. So the question you probably want to ask yourself is quite straightforward. In this case, it's let's see if I do that. I get my pen. So the pen is the question is, in 1 hour, if I record the color of cars amount, which is the most popular? Right, and we're going to collect our results in a tally chart. That's how we're going to do it. We could also decide where we're going to do it on a busy street, whereabouts in the middle of the road. The best place to do it would probably be at traffic lights or something like that, so that cars will be stopped every now and again and make it that much easier for you. And you could put your results in a bar chart, and then it would be easy to see which one's the most popular. Okay, something like that. You might have come up with something slightly different, and if you did, please let me know. Alright. Okay, different types of data. Okay, still repeating what we did last year. There are three sets of these, really. So the first one we're going to do is primary. And what's the difference between primary and secondary data? As a recap. Oh, this is so exciting. Well, primary data is data that you... If I can find my text box here. Sorry. There we go. Is that you collect yourself. So examples would be things like surveys or looking at observational data. So just watching people going about their business. How many people wear yellow jackets, for instance? How many people carry their phones in their pockets? You could observe that in people. Although, lumps in the pocket, you need to be careful about those things. Surveys, observations. So anything you collect yourself at all will fall into that category. You might do stock check and things like that would be other. You could do a stock check yourself. Secondary data is stuff that you obtain from somewhere else. Something like, there could be, there are national averages kept of things. You could get results of other surveys. It can even be things like attendances. So attendance is usually recorded by other people. Could be, enrollment forms, enrollment data can be secondary data. So when you all enrolled, you would have filled out an enrollment form. It can even be things like menus or timetables, things like that. They're all compiled by somebody else, and they're all forms of data. So they're secondary data, if you know what I mean. So any leaflets or pamphlets or things produced by somebody else is secondary data. So well and good. Okay, move on to the next. Discrete and continuous. Very often confused with each other, but actually fairly straightforward. Discrete data is counted, and continuous data is measured. Now, we'll do some exercises in this in class to make sure people don't get confused about it, but an example would be if I was trying to work out how many males and how many females are in our class. So all I would have to do is count how many there are. You know, there'd be so many males and so many females. And that's how I would do it. That would be discrete data. If I counted the number of times I went to the gym last month, in my case it would be 0, but for other people it might be, you know, a bigger number than 0, and for some people it would be an awful lot bigger than 0. But they would be able to count those number of times that happened. Now, what is measured data? Well, measured data is things like your weight, your height, temperature, things that are measured on a scale, anything that you can measure. And again, like I said, we'll do some examples of this that will try and confuse you with some of the language we use. But if you think about exactly what it is you're being asked to count or measure, you know, you'll get whether it's discrete or continuous. Last set is quantitative and qualitative. Right? So I'll start with qualitative actually. It's usually a word. So qualitative data is if I ask you a question, something like, what's your favorite pizza topping? And you would say pepperoni. There's no number in that. Nothing to do with that. You'll get an answer. What's your favorite type of dance? You know, do you like to do line dancing? Do you like to do a bit of jive? Do you like to do a bit of waltz? Do you like to do a bit of disco dancing, or are you just, you know, a free spirit dancer? You know, bit of a pointer with your toes and everything. Those kind of things. Anything that has a word as an answer. What's your favorite type of music? Will be qualitative data. Quantitative data is your answer will be a number. So it could be said that your quantitative answer will either be discrete or continuous. So sometimes in some of the questions you'll get a question that says, is this data discrete or continuous? Because they're the two forms of quantitative data, or qualitative, which is a word. And that's all there is to those different types and sets of data, which is great. Now, we will touch briefly on this, but most of this part is coming up in the next video, so how we collect data and represent data. We usually collect data in a table, like I've said, but more usually it's called a frequency table, and we've used the tally marks and things to count our numbers. They're grouped in fives, and 5 is called a gate, because it looks like a gate, a 5 gate. We've talked briefly already, but I'll sum it up again about questionnaires. So a good source of primary data can be questionnaires. Good practice guidelines, we've talked about some of the things to do with regards questions. Simpler the question, the easier it is to answer. If you give yes/no responses, people can easily identify which one to go with. Give a choice of answers rather than leaving them open, i.e. tick boxes. So if you're asking people how much they spend per month on food, you know, rather than just leaving it totally open-ended, group your data already. So give 0 to £50, 51 to 100, 101 to 150, etc. Give them the tick boxes to fill in. Make sure responses do not overlap or leave gaps that aren't covered, and never ask personal questions. People are less likely to answer them. We've covered those bits earlier on in the video. Okay, so that should wrap those bits up. We'll do in the next video. I'll start doing some examples of how we collect data and the difference between collecting discrete and continuous data. We'll look at how we represent some of these things by using stem and leaf diagrams, scatter diagrams, box and whisker plots, cumulative frequency graphs, etc. We'll start coming on to those, but until then, this has been a recap of last year's work for the most part. And if you have any questions, bring them in the class. Okay, speak to you later. Bye.